we try to solve some problem. So the first question is, which of this term is greater, 1.01 to the power 1 million or 10,000? We try to express the first term using binomial theorem. So this can be written as 1 plus 0.01 to the power of 1 million, which using binomial theorem can be expanded as NC0, which is 1, into 1 to the power 1 million, which is 1. So the first term is 1 plus second term. Second term will be NC1, 1 to the power 1 million minus 1, which is 1, into 0.01 to the power 1 plus other terms. So it will be 1 plus NC1. That is 1 million choose 1 will be 1 million into 0.01 to the power 1, which is 0.01 plus other terms, which is 1 plus, if we solve this, we'll get 10,000 plus other terms. Since all the other terms will be other positive terms. So we can see we have 10,000 plus 1 plus other positive terms. So this whole thing is greater than equal to 10,000. That means this one is greater than 10,000. Okay, the second question. 3 raised to the power 2n plus 2 minus 8n minus 9. Prove that this is divisible by 64. For this number to be divisible by 64, we need to simplify it. While we simplify, we try to get rid of these minus 8n and 9. So this 3 to the power 2n plus 2 can be written as 3 to the power 2 into n plus 1. We take only the first term. Okay, this can be written as 9 to the power n plus 1, which can be written as 1 plus 8 to the power n plus 1. Now using binomial theorem, we can expand 1 plus 8 to the power n plus 1, which will be 1 plus NC1, which is n plus 1 into 8 to the power 1 plus n plus 1 CT. 8 to the power 2 plus 1 plus 1 C3 8 cube, and all the way to 8 to the power n plus 1 n plus 1 C n plus 1, which is, if we look at these two terms, what we get is we get 8 plus 1, which is 9, and 8n. So it's we get 9 plus 8n. This term onwards, if we see, we have 8 to the power square, 8 to the power cube. So we can take 8 to the power square as common. It will be 8 to the power square The leftover for this term is n plus 1 C2 plus some other terms. Okay. Now, if we look at the expression, we have minus 8n and minus 9, which cancels out these two terms. So what we will be left over is 8 square into some number, yeah, some terms. And 8 square is equal to 64 into, so since we have 64 times something, we can say this is divisible by 64. Okay. Now we take a look at the next question, which is find the remainder when 5 to the power 99 is divided by 13. Here, okay, we try to see 13 and 5 are not multiples of each other. And even if we divide 13 by 5, the remainder we get is 3, so which is not helping. So we try something. What are the multiples of 13? There is 13, 26, there is 39. What are the multiples of 5? We have 5, 10, 15, 20, 25. We see that 25 and 26 are close together. So 5 to the power 99 can be written as 5 to the power 98 into 5, which is 25 to the power 49 into 5. We take this 5 out. We ignore this 5 for now. Okay. So 25 to the power 49 can be written as 126 minus 1 to the power 49. Now we expand this using binomial theorem. So I write the genetic term, which is NCR a to the power b to the power minus r. Sorry. We write the generic term, which is NCR a to the power n minus r b to the power r. So expanding this, we will get NC0 a to the power n minus r, which is 26 to the power 49 minus 49 C1 26 to the power 48 plus 49 C2 26 to the power 47, and last term will be 49C49, which is 1 26 to the power 0 1 to the power of 49, which will be minus 1. We see 26 is common in all, so we can take 26 what we will left over will be 26 to the power 48 minus 49 into 26 to the power 47 minus 1, and this whole thing was multiplied by 5. So we can put 5 here, we can put 5 here. Now when we try to divide this whole thing by 13, since there is 26, with this 13 into 2, this one will be divisible with 0 remainder. We have minus 5 here. So we have a number of the form 26n, or we can say we have number of the form 13n minus 5, and we have to find the remainder when this number is divided by 13. This can be written as 13 times n minus 1 plus 13 minus 5, which is 13 times n minus 1 plus 8. So here we see the remainder that will be left is 8. So this is the answer.